Hello. Today's lecture is the dualization of tropical curve. Sorry. In the previous lecture, I introduced what is a tropical curve. The following graph, in the previous lecture, we plotted the graph, the quadratic tropical curve. And that is a projected image on the XY plane. That shape looks like a tree branch. And I counted the number of vertices, edges, and faces. Because every vertices meet three vertices formed by three edges. Instead of vertice, we can use the term tree valence. Okay. There are 4 tree valences, 9 edges, and 6 faces. Okay. And we can think about the dual image of tropical curve. Dual, as we saw, between the relation cube and octagon. There, if for example, in a cube, not eight vertices. In octagon, in case of octagon, 8 faces. We changed dual relation as we saw between the cube and octagon. Likewise, we can think about the dual image of tropical curve. So, the 4 tree balances is changed 4 faces. Okay. In this lecture, we deeply think about what is the dualization, geometrical meaning of dualization. Okay. But before we think about this relation, we should think about the tropical polynomial, especially the expression of tropical polynomial. In the previous lecture, I explained the univariable. So, not multivariable means the univariable. Tropical univariable is degree D means that like this. Just one variable. This is one variable, we can univariable tropical. So called tropical univariable. But we can express what is a tropical multivariable. Something like this, fxy and fxyg. Okay, of course we can express some like this. Okay, but we can generalize how to express a tropical polynomial multivariable form. Okay. So we know the following tropical polynomial well. So let's think about again these guys. One, let's see here. If that is two variable, then let's think about the following tropical polynomial like this. That is x times x, but there is no y. Okay, that means we can express this monomial like this, and that is like this. And the third part is 1 times that, and the remaining term is we can write the remaining term like this. Okay, then, and in that case, we focus on the power of each monomial. That is 2, 0. That guy is 0, 0, 2. That is 1, 1, 1, 0, 0, 1, and the last term is 0, 0. So if we generalize a tropical multivariable, the power of x, y is play an important role to express a multivariable. So the expression depends on these index. Okay, so let's think about let's define the set S. In that case, collection of two integer tuple where I and j are power of tropical polynomial x, when, and y. Okay, but when we consider the coefficient each monomial, is not identity, 0. But in tropical system, 0 means identity, not minus infinite. If we define tropical sum is defined a maximum, or if we define tropical sum is defined the minimum plus infinite. Okay, that is depends on how we define tropical sum is defined the maximum or a minimum. Okay, So in this collection, based on the collection, in particular, we call the element of S is called, that guy is a tuple, is a vector, so exponential vector. Okay, that is the exponential vector. So based on this information, if it generalized tropical two variable, then in case of monomial, that is the index is from z to 0 to d, but two variable, we call the element is changed, so that is defined vector, collection of exponential vector, and the coefficient is defined Cij. That is I. That is Z. So where Cij means that each, when we think about the this polynomial, this coefficient is C22. Okay. Also C2 0. C2 0, because the coefficient x is 2 and y is 0. Okay. And in the case, the coefficient is just 0. Okay. That is minus infinite, not the plus minus infinite. That is just 0. Okay. That is the multiplication is defined tropical sum. So that is vanish it. So this, in this case, so C11 is a 0 coefficient. Okay. So anyway, we can generalize a multivariable, two variable tropical polynomial is defined like this. And when I think about a three variable, just in the case, just collection of S. But in the case, S is collection of I, three tuple IJL, okay, which satisfies the given condition. And coefficient is changed Cijk, okay, and variable k, okay, like this. So that is exponential vector. So so in generalize, we can generalize for n variable, we can define the generalized tropical polynomial. Okay, but that is technically very complicated. So just we use the notation I1, just to change the I1, I say k, ik, and exponential vector I1, ik, so In, okay, to n tuple exponential vector and x1, I1, xn, in. So that is generalized, is quite complicated, but we can express based on 1, 2, and 3 variable. We can generalize a tropical polynomial, multivariable polynomial.